PFAS in landfill gas raises new emissions and compliance risk. PFAS contamination has long been framed as a water problem. In the landfill sector, that's meant leachate, wastewater percolating through trash and routed to treatment plants, has taken center stage. But a new multi-state sampling effort highlights a different vector: the air. Researchers collected landfill gas (LFG) samples from 30 sites across 17 states, directly measuring volatile PFAS. The results suggest that emissions to air from uncollected landfill gas could be a significant pathway, potentially rivaling national PFAS release estimates from leachate. The study found a median PFAS concentration of 19,000 nanograms in LFG, dominated by fluorotelomere alcohols, FTOHs. Applying these data to national figures for fugitive landfill gas, researchers estimate an annual release of approximately 836 kilograms of volatile PFAS to the atmosphere. That number carries a wide uncertainty range, but remains broadly in the same order of magnitude as landfill-related PFAS releases to water. The implications are material. Volatile PFAS compounds like 6,2-FTOH and 8,2-FTOH can undergo atmospheric transformation into more persistent acids, meaning air releases may ultimately contribute to groundwater or surface water contamination as well. For landfill operators and regulators, this reframes PFAS risk from a cross-media perspective: collection, combustion, and the compliance gap. Beyond identifying PFAS in landfill gas, the study raises difficult questions about control. Two factors drive national emissions: how much gas escapes collection and how effectively combustion systems destroy PFAS in collected gas. The researchers used EPA datasets, including the Greenhouse Gas Inventory and LMOP data, to estimate fugitive gas volumes. But a key assumption in the study, that flares and engines destroy 100% of PFAS, is based more on regulatory convention than empirical certainty. In a sensitivity run with 50% destruction efficiency, PFAS emissions doubled. This matters for capital planning and permitting. Many landfill owners rely on flaring systems or internal combustion engines to manage LFG, with environmental compliance based on assumed destruction. If those systems are less effective than believed, facilities may face rising scrutiny around air toxics and fence line emissions. The study also looked at how gas system design affects sampling results. Comparing upstream and downstream samples from condensate knockouts showed little PFAS concentration change, suggesting moisture removal earlier in the well field may capture PFAS that would otherwise partition into condensate. This has implications for technology vendors aiming to quantify or remove PFAS through condensate-focused approaches. For operators, the most immediate lever is improving gas collection efficiency, assuming PFAS destruction is validated. For the longer term, upstream product restrictions and chemical phase-outs remain the only durable way to shrink the PFAS burden in landfill-bound waste.